Okay, hi there. Now that you've finished testing out different electrical devices, let's talk a little bit about AC and DC electricity, and let's talk a little bit about grounding. So, AC DC electricity there are two different types of electrical energy, two different ways that electrical energy can be delivered through your wires. AC stands for alternating current, and DC stands for direct current. Let's talk first of all about DC. And turns out that batteries and solar panels create DC electricity. And the idea with that is that in DC electricity, the electricity only flows in one direction. Okay. So as an example of that, I'm going to click down on the bottom of the page here. And on this slide, there's a little link here. So if you have a direct current circuit, right, then you have a battery, say with a light bulb. If you were to look inside of that wire, what you would see is you would see the electrons being pushed in one direction around the loop. They're pushed away from the negative through the light bulb and back into the positive, and they just keep going around over and over. In other words, the electrons only go in one direction. So that's called direct current. And that's what batteries do. Now, the other type of electricity is called AC. That's alternating current. And this is the electricity that's delivered to your home through outlets and wires and power lines. And the reason is AC is more efficient power to deliver to your home, and it's also very easy for the power company to make it. Okay, so let's come back for a second. And the idea with alternating current is that, like, if you look at a lamp in your house, you plug in a wire into an outlet, and what happens is that the electrons, they kind of jiggle, right? They get pushed back and forth. And as they get pushed back and forth, they can transfer energy to the light and run it. So it's just a different way of kind of delivering electricity to you. It turns out that in AC, that the jiggling is pretty fast. So these charges move back and forth about 60 times in 1 second. And again, that has to do with the way that the power company generates the electricity. If you were to look at a graph of the voltage that comes from an outlet, you would see that the voltage goes from 0 to something high and positive, it goes back to 0, and then it changes direction and it flips negative. So every time this graph goes down in the negative part, it's causing the electrons to go in the opposite direction. And then they switch back when they go into the positive. Okay, so that's called AC. Okay. On the next slide, that's in activity 8-1, a couple more graphs. I think we've talked about the one on the bottom here. The voltage from the power company goes up and down, and the current that goes through your appliances goes up and down, and it changes direction. DC up here, you can see that it's kind of like there's not a lot, but it's just pushing 9 volts or whatever. It's just always steady and the same, and the current is the same too. So kind of to make a connection with something you did in the activity today is, remember you kind of looked at the different slots in a duplex outlet. And what happens now is that the smaller slot, it's called the hot, that's the one where your current or your voltage comes into the outlet through a wire. And this is a dangerous one, right? Because you've got something which can be up to 100 volts or more, right? And so that's being delivered through the gold screws, right, into these short slots. Now, once the electricity is sent to like a light or an appliance, the energy that it contains is largely gone. It's been used. And so the electricity that comes out through these longer slots. Those are called the common slots. And that electricity then returns to the power company. So remember that all electricity, has to complete a circuit. So it's not enough to just send high energy electricity to an appliance. You have to give the electricity a way to get back to the power company. So this large slot is called the common slot. Sometimes it's called neutral by electricians. So common or neutral. Another point of interest is that if you think about it, why do you think that they make the hot slot to be so small And the reason is because they want to make it difficult for kids who might want to stick something into an outlet, because this is the dangerous one, the red, right, the hot. So that's something there. If you want to match up this picture up here with the image down below, I don't know if you can see this, but the red power going in would be like the top part of the circuit. And the blue coming out, the common or neutral, that's like this bottom wire. So it kind of makes the connection between the outlet and the circuit. Okay. One more thing. Going back to the outlet, you may have noticed that there's a round hole on each of these things, right? That's actually serves a very important purpose. It's called a grounding hole. And let's talk a little bit about that and why you need that extra connection, okay? So ground and grounding. We call any place that always remains at a potential of 0 volts an electrical ground, okay? And grounding an object is placing it in electrical contact with a place that always remains at 0 volts. In a home circuit, this is done by connecting your ground wires to metal pipes that run into the ground. So if you ever go in your basement, you're going to see probably connected to some water pipes, you'll see a cable, a thick copper cable that goes into your electrical box. And that cable, the fact that it goes to a water pipe is important because a water pipe is going to always be safe to touch from an electrical point of view. Water pipe goes into the ground, and the ground is at 0 volts. And so when you come back and you look at the outlet, that green screw, right, the little green screw that's down here, actually connects through a wire to that water pipe in your basement. And it also connects these round parts of the plug, that third prong right there and there. And that's a good thing. That's called your ground connection right there. Also, those grounds are connected to the top and the bottom screws, right? These are the screws that are used to mount the outlet onto like a junction box, okay, or a cover plate. So if you look over on the right side of the slide, you know that you have to connect like switches and outlets into some type of a box. And when you connect them into a metal box and put a metal cover plate on, you're really protecting yourself because you're forcing those things to be grounded, right? Because there's a connection between this green screw and these other screws that are used to connect. So the point is that anything that you can touch that's metal on the outside should be safe. And you want it to always be at 0 volts. And that's how you do it, is you have to connect a wire to this green screw and then attach your device accordingly. Okay. There is a little explanation here about how grounding protects you. I would recommend reading this. So there's a link on the slide. But long story short is that think about an appliance in your house like a washing machine. It is possible that maybe someday a wire comes loose, say the hot wire. And inside the machine, the hot wire is going to touch some like the outside of your washing machine. That would be dangerous because it would mean your whole washing machine would be at 110 volts. So if you come around and you touch it, now electricity is going to go through your body and use your body as a way to get down to 0 volts. You're going to get a shock. So the way that you can protect from that is you can use a grounded plug, which has an extra wire in it down here. And what would happen is if you had this fault in your washing machine, if there was like a busted wire and it touches the wrong place, the electricity will go through this extra wire into the ground. And it won't go through you because the wire is an easier path for the electricity to go through. By the way, as soon as that happens, as soon as that extra electricity goes through this way, it's probably going to trip your circuit breaker and it's going to shut down that circuit, which you want it to do because you got to take have someone look at your washing machine to fix it. So that's a quick story, but usually appliances in your house, like big appliances, always have the plugs that have all 3 prongs, right? And you need that third prong, that round one. That's the one that goes to the ground. One other type of thing here that can protect you in your house, that you probably will see this in your kitchen or your bathroom, is a ground fault circuit interrupter. It's GFCI. This is a smart outlet. And what it does is it looks at the amps that come out of the hot and the amps that come out of the common. Actually, the amps go in through the hot and then they come out and go out through the common, right? And it looks at those amps, the amps going in and the amps going out. If they are the same, if they're equal to each other, that's good. And that means all the electricity is going to your toaster or your hair dryer. That's normal functioning. However, let's say that you drop your hair dryer into the sink, and now all of a sudden the amps going in, some of those amps are going basically in through the water in your sink to ground, and they're not actually ever coming back through the outlet. So if these two currents aren't equal to each other, that's bad, right? If you have more amps going in and less coming out. And what the GFCI will do, what this outlet does, is it's a smart outlet. And if it notices that, it will immediately open the circuit and it shuts it off. So you probably notice on these things, there's a test button and a reset button. And if you push the test button, it'll shut the power off, because what it's doing is it's just making sure that this all works. And then you reset it to reset it. So that's pretty much it. I hope in this little, in these slides, you learned something about ways of protecting yourself by grounding. I hope you've learned about where the ground connections are, what they connect to. And also we talked a bit about alternating electricity, alternating current electricity, and that's the type that we use in our homes. And we kind of contrasted that with direct current electricity. Okay, so I hope that was helpful. Bye-bye.